Alright guys, let's get going on example 3, which example 3 is really similar to example 2. Like I said in example 2, we're going to have to take this problem one step further, but I'm confident that you guys probably know that extra step. So if you want to try example 3 on your own, go for it. That's a thumbs up. Go for it. Okay, otherwise, if you want to kind of run through it again with me, that's perfectly fine. So go ahead and follow along and we'll have super doubly awesome catastic fun together. Let's get going. Okay, so eventually it says to find the measure of R in M. So eventually I want to know what this angle is right here. I don't know it. Okay, as which if we're thinking back to that awesome theorem we talked about earlier, which that's not what that is. But anyways, sorry, thought I had this slide up. Anyways, we're going to be looking at this property, which again states if you have an angle created by either two chords or two secants, okay, and they intersect inside the circle, if you add up the two intersecting arcs, which on this one are the ones to the left and right of it, and divide by 2, you will get the measure of the angle. So that is the theorem we're going to be using again. Okay, but we're going to have a dilemma. So looking here, since this angle is kind of opening up toward the left, I need to look at intersecting arcs that are to the left and to the right. But if you guys see here, I currently don't know what those two arcs are. The intersecting arcs of this angle are arcs RM and QP. And I currently don't know what they are. So I have to go a different route. Do you guys see some other intersecting arcs or something else that might help me to eventually get to that angle? Well, currently I have the arcs MQ, and technically there should be another point because this is definitely a major arc, but that's okay. Arc RP this way, so be careful. Technically I have arcs MQ and RP. Okay, so which two angles are intersecting those two arcs? So there's two angles that are intersecting them. Okay, the angles that are intersecting them, since these arcs are kind of up and down, what are the angles that are kind of facing up and down in this problem? Do you see them? Of course you do. You always see it. Okay, so the angle M and Q is facing upward, so I could use that angle, or I could use angle R and P. Those are both opening up or down, which means their relationship will hold true with the arcs that are also up and down. Okay, so it actually doesn't matter which one we use. I just chose to use angle R and P, so this one right here, but you could use M and Q as well. Okay, let's get going. And another thing, it doesn't matter which angle you use, because technically since these angles form at the X, which angles form at the X? Yes, it is the vertical angles. And how do vertical angles relate to each other? They are congruent. So since vertical angles are congruent, I could use either of these because they're the same. Okay, so I'm going to use angle RNP, which I'm going to use, let's see, I think I'm going to use orange this time. So angle RNP is this one right here. Okay, and then the intersecting arcs are the ones, since it's facing down, I'm going to use the arcs that are below and above that bad boy right there. So I'm going to use the two arcs that I'm given, which are arcs. Technically, again, there should be another point because it's a major arc, but that's okay. The demon cats got me when I made this problem. Okay, so arc RP is this arc right here. And this one, these are my two intersecting arcs. Okay, and I guess I didn't explain why I chose to use this angle. So, first of all, I chose to use it because we were given these arcs. But do you guys see a way you can use angle R and P to eventually get to R and M? What do those two angles form when you put them together? Which I'll try to, let's see if I can do it this way. Okay. What forms when you put together angle R and P and R and M? What are they both sitting on? They're both sitting on a line. And what do the angles in a line add up to equal? They do, in fact, have to be 180. So if you know one of the angles, if you subtract from 180, you will get the other angle. So ultimately, if I find angle R and P, if I subtract from 180, I'll get R and M. All right, let's keep on going. All right, so I'm going to set up that special relationship that we talked about on the Prezi video. All right, let's get going. Sorry, I'm trying to decide on my color. It's always a hard choice deciding on colors. Okay, I'm going to choose to use this teal kind of color, this aqua blue color. So the measure of angle RNP equals 1/2 the sum of my intersecting arcs, which are arcs, again, I'm going to call RP, but that's wrong. RP, okay, plus the measure of arc MQ. Sorry guys, I'm running out of room like normal. So that says the measure of arc RP plus the measure of arc MQ. All right, let's fill in our values. So the measure of angle RNP equals 1/2 of arc RP, which is 225, plus arc MQ, which is 91 degrees. All right, guys, let's get this bad boy going. Let's do this thing. Okay, so the measure of angle RNP equals 1/2 of 225 plus 91, which 225 plus 100 is 325, subtracted by 1 is 316. All right, let's keep going. So this is 316. I'm going to use purple to keep it color-coded. Sorry, I'm being a little OCD right now. All right, and then I simply just have to have it to get that angle, which means I'm one step closer to getting to this angle. So let's get going. So the measure of angle RNP equals 1/2 of 316, which half of 316 is, let's see here, 158. So it equals 158 degrees. Sorry, that's 158. The demon cat's got me a little bit. Okay, so we know that the measure of angle RNP is 158. Okay, so I'm going to label out my picture to help me as I'm solving. So this angle right here is 158 degrees. All right, so since I know this angle, these two angles right here, like we just talked about, form a line, which I'm going to try to bold them so you guys can see it better. So RNP and RNM, which is this one right here, they both form this line right here. Okay, which means they have to be 180. So the measure of angle RNP plus the measure of angle RNM will add up to be 180 because they're supplementary. Yay! All right, guys, let's get going. Let's substitute in these bad boys and get the show on the road. So the measure of angle RNP is 158 degrees. All right, plus the measure of RNM equals 180. All right, let's get this bad boy by itself. How do I move 158 to the other side? Oh man, you guys are correct. You do subtract it from both sides, 158. Okay, 158 minus 158 cancels. Bam, and turns to 0. And then 180 minus 158, well, 180 minus 160 is 20 degrees. Added 2 more is 22 degrees. So I'm kind of out of room, but the measure of angle R to the N to the M equals 22 degrees. Insane. I know. Totally insane. All right, wasn't that fantastical? I know, it was. Thanks, you guys, for having a great time with me.